Assalamualaikum. We are from UniKL student and we are going to introduce you our product that is dual axis solar tracker. This is our group member from team 2 course WQI. First is myself Nakiuddin Asfar, second Muhammad Hazam Amin, third is Ahmad Alif Aiman and lastly Muhammad Ikmal Hakimi. Let's begin.
Overview of the project. Solar tracker play an important role in order to maximize the energy generation and improve the efficiency. This project performed the construction and the design of inexpensive active dual-axis solar tracking system to tracking the motion of the sun as to get maximum power from the solar panel as they follow the sun. Next. Light dependent resistors were used to sense the position of the sun from time to time, which synchronized with an Arduino Uno microcontroller, which then commands a set of two servo motors to reorient the panel to perpendicular to sun rays. The integration of the design was tested using LabVIEW to determine the improvement of efficiency. Results show the new system performed 23.31% better than the immobile static solar PV system. The problem is the direction of the sunlight is always changed depends on the movement of the sun in a day. Mostly, the existing solar panel was installed statically, means that it does not move to follow the position of the sun. So the hypothesis is this project was chosen by placing two servo motor for solar panel to rotate in two axes with light dependent resistor to sense the light intensity of the sun and get activated during daylight. In this project, the solar system enhanced with use of sensor to light intensity. The component used is light dependent resistor. The objective. First is to develop a prototype which monitors and control automatically track the movement of the sun. Second, to design a control and monitoring system by using Arduino and complete it with IoT system. And lastly, to determine the power efficiency between dual-axis solar tracker and static solar tracker.
Project functionality. First, in terms of energy, decrease energy consumption for the application of global expectations of the establishment and ideal execution cost proportion. Second is in terms of energy production, generate a greater amount of electricity during peak times of the day in the same amount of space needed for peak system. Last is in terms of quality, reliability quality in task under various different trouble conditions, thus rain, wind, important temperature variations. Next. Justification of IoT. This dual-axis solar tracker will provide an up-to-date technology for the customer to easier their daily life. With an IoT technology it includes into product, it will give directly on time the data that has been inside into the dual-axis solar tracker. Second, it is mostly present before an audience. It serves a variety of purpose, making presentations powerful tools for convincing and teaching. Lastly, is to create a story presentation. It best to simplify a talk, start with an outline of topics and identify highlights, which can be applied to whatever subject you plan on discussing.
The next slide is about our interface design. These are the examples of how our interface design would look like. The next slide is about system flow. How it is done. The light dependent resistor measure and change intensity of something. The sensor then signal the Arduino. Arduino process the signal and send data to National Instrument LabVIEW. In the meantime, Arduino signal an input to National Instrument LabVIEW to show the result of a calculation to move the servo meter for the angle of solar panel. Now I want to show you our workflow. This is our workflow.
Next is for the marketing. This is our business opportunity. As the government around the world have recognized the need of alternate energy to tackle climate change, solar energy is considered a best alternative. Government subsidies and declining tariff price are propelling the solar energy market. With the rise in the solar energy market, the demand for solar tracker has increased. Highlight number 1. These solar trackers are used to capture the maximum solar energy throughout the day and increase solar panel output and efficiency. Highlight 2. The global solar market is driven by increase in energy demand worldwide. Highlight 3. The factors such as environmental pollution, rise in price of fuels, and growth in awareness among people regarding clean energy are expected to drive the growth of global solar tracker installation. This is our conclusion. The main outcome of this project is to design and implement a position control system for photovoltaic solar panel in order to provide a maximum output power from sunlight. In this project, the objective is to develop a prototype which monitor and control automatically track the movement of the sun. In order for optimize the efficiency of photovoltaic solar panel, which is to absorb the light intensity of the sun with a position control system that was installed in light system that was integrated in solar panel system. And lastly, this project is already regarding the efficiency of low output voltage from panel was low as the sun moved to other position. There was problem that been encountered by producing active solar tracker where the system follow the sun as it rise in the setting. This will keep the system with solar panel exposed to maximum light intensity facing the sun all the time. Thank you.